Okay, so today we're going to go ahead and use Newton's second law to solve problems that involve forces not just in x and y direction, but both directions. So what I want you to do, go ahead and read number 1 to yourself, and I want you to do A, draw a free body diagram, pause this video, and then check back in. Okay, so now that you drew your free body diagram, I'm going to go ahead and draw one too. So let's see, I have this is on some level surface right here. We have some applied force, which we're calling F at an angle. Gravity is going to act downwards. We have Fg downwards. We know this is a problem all with variables, so I'm just going to label that's going to be mg. We got a surface pushing up on it, so we got Fn. And then it says there is friction, so it's pulling to the right, so friction's got to be the opposite way. Ff is going to be that way. So that is our free body diagram. If we do a graded free body diagram for the AP exam or for class, that's what your free body diagram looks like. Cool. So we did our first step. Let's go to the second step. Let's choose our coordinate system, positive and negative direction, and x and y. So I'm going to say up and down direction is the y direction. I'm going to say this direction is the x direction. The horizontal is the x. So let's see. Are there any forces that are not just x or just y, but both directions? Let's see. Fn is just y direction. Ff is x. Fg is just y. This F force looks like that's both x and y. So we're going to go ahead and split that into its components. So let's see. I'm going to go ahead and split that into its components. So I'm going to say this is Fy, which if we do a little trig, I'll do it to the side. So this is F, this is theta. Let's go ahead and set up our SOHCAHTOA. So if I were to solve for the y direction, that is opposite. F is the hypotenuse, so I'm going to use sine. And this again was Fy. So sine of theta equals Fy over F. So Fy is going to be F sine of theta. Great. So I'm going to put that on there. This is F sine theta. If we do the same idea, use some good old trig, the x direction is going to be Fx equals F cosine of theta. Okay, I'm going to go ahead and redraw this free body diagram for thinking purposes. So we're going to say we have Fn going upwards. We have Fy, which is F sine theta. I'm not going to label F on my redrawn free body diagram because we broke that into our x and y components. So I have Fx is F cosine theta. We have Fg, which is mg. And then we have Ff. Cool. So now I'm just going to use a new free body diagram for like my solving purposes. So we did step number 2. Now let's do step number 3. Write out the second law, F net, for x and y directions. So for B, we want to find the force exerted by the surface on the block. So I want you to think about what that is. Okay, so the force exerted by the surface on the block, that is going to be the normal force. So we want to find the normal force. That is a force in the y direction. So I'm going to set up F net y. So what I want you to do, go ahead and write what force or forces are in the y direction, and then check back in on this video. Let's see. So in the y direction, it looks like that's the vertical. We have Fn going upwards, that's positive. We have Fy going upwards, positive. And then Fg going downwards in the negative direction. Cool. Let's go ahead and add a little more detailed things we know. F net is always equal to mass times acceleration. Fn we want to find. Fy is going to be F sine of theta. And Fg is minus mg. Okay, mass times acceleration. I want you to think about what is the acceleration in the y direction. Okay, in the y direction, it is not moving in the y direction, so that acceleration is going to be 0. So it's m times 0 equals Fn plus F sine theta minus mg. So this is going to be 0 equals Fn plus F sine theta minus mg. So now we can just go ahead and solve this for Fn. So let's see, Fn is going to be mg minus F sine theta. Cool. And I want you to think about this. So Fn, that's the force of the surface pushing up. Does that surface have to push up as much if someone is pulling up on the surface? No, it doesn't. So that's why Fn is a little bit less than Fg. Just Fg or mg by itself. Cool. Let's go ahead and look at part C. So for part C, we want to find the acceleration of the block. So I want you to think about what direction is it accelerating? It is accelerating in the x direction. So let's set up F net x. Go ahead and do that yourself and then check back in on the video. So let's see, F net x is going to be, let's see, we have fx and ff in the x direction. So fx is going to the right, positive direction, minus ff. So then f net, we know that is going to be mass times acceleration. Fx is going to be f cosine theta, minus ff, our equation for that is coefficient, times fn. So the only thing allowed in our answer are variables given in our problems and like fundamental constants like g, acceleration due to gravity. So it looks like we're not allowed to have fn. I want you to think about what to plug in for fn. Oh, after you've had a chance to think about it, or you figured it out, we can plug in fn from our previous problem. So we have ma equals f cosine theta minus mu times mg minus f sine theta. And we just need to solve for a, so we can just divide both sides by m, and we're in business. So our final answer is a equals f cosine theta minus mu times mg minus f sine theta, all divided by m. Awesome. Great. Thank you for watching.